Graphing transformations using mapping notation. Example 4. Reciprocal functions. Graph g of x equals to -2 multiplied by f at open square bracket 3/4 open round bracket x plus 2 close round bracket close square bracket plus 3 by transforming the base function f at x equals to 1/x. Step 1. We're going to graph the base function using nice points. Step 2. We're going to rewrite function notation as mapping notation so that we can perform step 3, which is finding the image points. And then step 4, we will graph the image points and label the new function. Step 1. Graph f of x equals to 1/x using nice points. Before finding the points, it is a good habit to graph the asymptotes first. They serve as skylines that help us draw the graph by hand. The asymptotes are x equals to 0 and y equals to 0. So we draw these lines using dashed lines, not solid lines. Remember to label them. Once the asymptotes are sketched, we try to find some nice points that we can use to graph the base function. Usually, I choose these 6 points. 2 of them are integer points, and then the other ones use the value 1/2 or -1/2 because they are the closest ones to some nice values. So I sketch A, B, C, D, E, F onto the grid, and then we connect the dots nicely using the asymptotes as guidelines. Remember that the curve should not touch or cross these asymptotes. And then when I sketch it, I have my graph. Remember to label f of x before we move on to steps 2 and 3, which is rewriting function notation as mapping notation. So g of x has a being -2, k is 4/3, d is -2, c is +3. So I write that in mapping notation form. So I have 4/3 x subtract 2 and -2y plus 3. And then I can perform some calculation to find my image points. There's 6 of them in total. We sketch the image points, and before joining the points to each other, let's remove the original function so that it's easier to read. So we can see our points A prime, B prime, C prime, D prime, E prime, and F prime clearly. Before I join the points, it would be nice if we can have the asymptotes for this graph drawn first so that it's easier for me to draw the curves after. So to find the asymptotes, I look at some points that are close to each other. So I'm going to look at point A prime and point F prime first. I'm going to visually, in my head, move F prime so that it's underneath A prime. So in my mind, I draw an extra dot on the grid. So now I'm going to compare A prime with this new dot, and I want to find the midpoint between them. Okay, so it's 2 units long, so the middle would be 1 unit. And then I draw my asymptote from there. So that's my horizontal asymptote. Next, I want to draw a vertical asymptote. I'm going to use the points C prime and D prime. So I'm going to imagine that D prime is going to move to right next to C prime. Okay. So I draw a dot there in my mind. And then I'm going to find the midpoint between C prime and this new point. And then I'll draw the vertical line like that. So I have my two asymptotes. So now it's easier for me to finish drawing the curve. So as you can see, now my curve is done. So I use the asymptotes as guidelines so that the curve does not cross or touch these asymptotes. So I'm going to add the original curve back on. It looks a little bit messy, but when we're sketching by hand, we do expect to see all the curves on the finished graph. And lastly, we need to label the functions and their asymptotes, all of them. Write an equation for g of x. We'll start from the substitution part. Given that f of x equals to 1 over x, which is the y-coordinate, f at 3/4 is the same thing as 1 over 3/4, and we can simplify it to 4/3. F at x plus 2 equals to 1 over x plus 2. F at 3/4 multiplied by x plus 2 equals to 1 over 3/4 times x plus 2, which simplifies to 4 over 3 times x plus 2. Now we want to find the reciprocal equation for g of x equals to -2 multiplied by f at 3/4, open brackets, x plus 2, close bracket, and then close the square bracket, plus 3. So we replace the whole thing of the function part with 4 over 3 times x plus 2. So g of x equals to -2, open round bracket, 4 over 3 multiplied by open round bracket, x plus 2, close round bracket, close the other round bracket, plus 3. Simplifying this equation, we have negative of 8 over 3 bracket, x plus 2, close bracket, and then plus 3. Now let's look at g of x. We can interpret the transformation in different ways. We can look at it as a reflection of f of x in the y-axis, a vertical stretch by a factor of 8, a horizontal compression by a factor of 1/3, a horizontal translation of 2 units to the left, and a vertical translation of 3 units up. We can also look at g of x in another way. We can see it as a reflection of f of x in the x-axis, a vertical stretch by a factor of 8, a horizontal compression by a factor of 1/3, a horizontal translation of 2 units to the left, and a vertical translation 3 units up. Note that the translations give us information about the asymptotes. So looking at g of x, our asymptotes are x equals to -2 and y equals to 3. Those are the equations of our asymptotes.